Okay, so what we're going to learn today, there's actually two ways to do it. When we factor trinomials that have a first term coefficient, that's what this A is going to be for here. There's the box method and slide and divide. Okay, so keep that in mind. There's two ways. I'm going to show you both ways today, but after today, you can choose which way you want to do it. All right, so just a little warm-up or bell ringer. It says, which is one of the correct binomial factors? You had something like this on your quiz on Friday. So you just need one of the factors. So in order to get one of the factors, we need to just get both of them. So the factors of 18 that subtract to 3, okay, we know we're going to have a plus and a minus. I know I usually put the plus or the sign here first, but I'm looking for the factors of 18 that subtract to be 3, and it's 6 and 3. I know the negative is going to go with the bigger factor, so I'll put the negative there. And x. Okay, so which one do I see here? I see x plus 3, so that is one of the correct binomials of that trinomial. All right, so let's get right into the box method example. From now on, when you see a first term coefficient, in this case we have a 3, you need to look for GCFs now. All right, do they all have a variable? No. Does 3 go into 14 and 8? No. All right, so this is when we're going to have to do something different, a little different. So box method, think about when we multiplied a binomial times a binomial. All right, we put our answers on the outside. Okay, so if we're going to factor, we're going to find the factors, then we're going to put what's in the box or what's in our trinomial, some of it in the box. We put the first term in the first box. We put the last term in the last box. Once you put those in there, multiply them. So without the variable. So 3 times 8 is 24. All right, we know our signs on our binomials is going to be two positives because it ends in a positive and the middle is positive. So we're looking for the factors of 24 that add to be 14. The factors of the 24 that add to be 14. So we have 1 and 24, no, 2 and 12. 2 and 12 are our factors. So I'm going to put those in the boxes here. But I also need to put an x with them, all right, because they have to add up to 14x in the middle. Now, I filled in my box, so now I'm finding the factors or the GCF of the rows and the columns. Okay, I'm going to find the factors of the GCF of these factors. So I'm going to look at 2x and 3x squared. What do they have in common? They have an x. That's the greatest common factor. 8 and 12x, what can I divide both of these by? The greatest common factor is going to be 4. And now reading up, I have 3x squared and 12x. Well, I know they both have an x, and 3 can go in both of them. And then I have 2x and 8, so the GCF is going to be 2. You can check x times 3x is 3x squared. X times 2 is 2x, 4 times 3x is 12x, and 4 times 2 is 8. So there's our binomial factors. The last step is just to write them as a binomial times a binomial. All right, let's look at one more example of box method. All right, there is no GCF here, so I'm going to go straight to my box. My first term goes in the first box. My last term goes in the last box. Then I multiply the coefficients here. 3 times 10 is 30. I'm looking for the factors of 30 that add to be 17. And they are 2 and 15. So I'm going to put those to finish filling out my box. And remember to put an x with them. That's how they add up to the middle term, 17x. Now I'm finding the GCF of the rows and the columns. It doesn't matter where you start wherever it's the easiest for you. I see 2x and 10 here. All right, so 2x and 10, let me change my color. 2x and 10, the GCF is going to be just a 2. All right, and let's see, the GCF of 3x squared and 15x is going to be 3x. You guys should be good at finding GCFs. 2x and 3x squared, the only thing I can divide both of them by is x. And 15x and 10, the only thing I can divide both of them by is 5. Now remember, if I have a positive end term and a middle negative, then both factors, both binomial factors are going to have negatives. So I fill them in. 3x minus 2 is on across the top, and x minus 5. There's my answer. There's the factors of that trinomial. So again, this is the box method. I told you I'm going to show you another method, which I will tell you that students prefer. So, slide and divide method. The way that we do this is you slide your coefficient, that first term coefficient, to the back, or it's at the end of the trinomial. So some people think it's to the front, to the back, it's to the end of the trinomial. And then you're going to multiply by c. So you're taking the first term coefficient, sliding it to the right, or the last term, and you're going to multiply. Then you factor like normal. We're going to divide both numbers in the answer by the number that we slid. If it divides evenly, we're going to write the new answer. If not, your denominator goes to the front. So that sounds like a lot of steps. All right, but we're going to put those steps now in action. And we're going to do a couple of these using slide and divide. Okay. All right, so slide and divide examples. So there's a first term coefficient. Let's make sure there's no GCF here. They don't all have a variable. I can't divide 3 into 8, so no. So if I take 3 and I slide it to the back or to this last term here, all right, slide it, and then we're going to multiply 3 times 8, kind of like what we did in the box, right? I'll just write what 3 times 8 is right over here. Got to write it over to the side, right? And then, just like we used to do your 2 sets of parentheses. You can fill in your signs. It ends in a positive, so you know they're both positive because the middle's positive. Now, instead of finding the factors of 8, we're finding the factors of 24 that add to be 14. What are the factors of 24 that add to be 14? 2 and 12, right? So, put a 2 there, put a 12 here. All right, this is very similar to how we factored trinomials last week. But the last step, well, the second to last step, step 3 says to divide both of your answers by the number that you slid. We slid this 3, so we're dividing these numbers by the number that we slid. Just those numbers. Now, step 4, the last step, if it divides evenly, we write the new answer. I see that this one, the second one does divide evenly. So this one's going to be x plus 4 because 12 divided by 3 is 4. But the first binomial does not divide evenly, so it says you write your new, if not, your denominator goes to the front. The denominator is 3, so we write 3x plus 2. And then this is our answer. Now, take a look back. This was the first one we did in the box method. We got the same answers. We got 3x plus 2 times x plus 4. Look back at your work. See the box and you see slide and divide? All right, let's look at this next one. Again, we just did this one. Let's erase this. If you need to go back and get that answer, go ahead and get it. But I needed to move it so that I could finish doing what I need to do. All right, slide and divide. we're going to slide the first term over here. There's no GCF, all right, and we get 30. I do my binomials. My end term is positive, the middle is negative, so that means they're both negative. This is how we did it last week. But now, instead of finding the factors of 10, I'm finding the factors of 30 that add to be 17, and they are 2 and 15. Step 3 says divide both of your answers by the number that you slid. We slid 3. And the second one divides evenly. 15 divided by 3 is 5. But this first one does not, and it's simplified 2/3. So we put the denominator 3 in front of the x minus 2. Keep the signs the same. And that is slide and divide. Now look back at the box method one, the second one that we did. It's the same question. Okay. And see if you like doing it slide and divide way rather than the box. It is the same exact question. All right, we're just going to do a bunch of these together. I'm going to do both ways, but again, like I said, after this, you can decide which way you want to do it. All right, so sometimes polynomials are prime. What does prime mean? All right, it means that only one in itself can multiply to be it. So here's a good example. All right, this does not have a GCF. 2 does not go into 5. They don't all have x's. All right, so if we were to slide and divide this to check, we have 2 times 2, right? And we get a 4, and we're looking for the factors of 4 that subtract to be 5. All right, the factors of 4 that subtract to be 5, all right, 4 minus 1 is not 5. All right, that's 3. And 2 times 2 does not subtract to be 5. It's 0. So therefore, nothing works. So it is prime. That can't be factored. Okay, it's prime. All right. You have 3 examples. Classes. Oh no, we'll do this example together. All right. So we're checking to see first if there is a GCF. Okay, there is no GCF. Nothing goes into all of these. So we are looking for the factors of 30. If we were to slide and divide, 6 times 5 is 30, and we're looking for the factors that add to be 17. All right, 1 and 30 does not add to be 17. 2 and 15 does add to be 17. Those are the correct ones. So if we were to put these in a box, we would put the first term in, well, I always put the first and last term in first. Then I multiply, and then I fill in my factors. We find the GCF of the rows and the columns. That's what we get. There's our binomial, and our factors are going to both be plus in the middle. Okay, again, you can do that as a slide and divide way also. If you did it as slide and divide, you would have had, let's see, this is slide and divide way. You would have had x plus 2 and x plus 15, right? And you would divide by the number that you slid. Okay? Neither one of these divide evenly, but they can be simplified. 2/6 simplifies to 1/3, right? So 1/3. So that means we would do 3x plus 2 is one of the factors. 3x plus 1, sorry, which is this one. And then 15 divided by 6 simplifies. 5 can go in, or 3 can go into both. It becomes 5/3. Or 5 halves. It becomes 5 halves. And so the other binomial factor is 2x plus 5. Because this simplifies to 5 halves. So the 2 goes in front of the x and the 5 is last. All right, this video is going to end. I'm going to have to start another one for you, so just go ahead to the next video.